Okay, so here we have a 4-bit bus organized CPU. We have buffered input, 2 tri-state registers, an ALU, and buffered output to an output register. The way I have this set up is that each tri-state device will float when its control switch is set high. For example, the input buffer is controlled by this switch, and you can see it's currently floating as its input switch here is set high. The same with register A and B and the output control. So what I'm going to show you is how to do various arithmetic and logic operations on a set of 4-bit numbers. First thing we're going to do is we're going to start the simulation, and we're going to load 2 values onto registers A and B. How we're going to do this is by first enabling the input buffer. Since it's set to 0, the input buffer is no longer floating and has access to the bus. So the first set of values that we're going to load is going to be 1, 1, 0, 1. And this is least significant to most significant going down. And we're going to load that into register A. Now, we're going to do this by stopping A from floating by setting its control low. And you can see that the bit pattern got pushed onto the A register. And now we're going to set A floating again. Now it's no longer connected to the bus, and we can load the values onto B separately. We're going to load the bit pattern 1, 0, 1, 0 onto B, and we're going to load that the same way we did onto A, by stopping B from floating, and we can see the pattern got pushed onto B, and having B float again. Now it's disconnected from the bus. Now what we're going to do is we're going to disable the input buffer so that's not affecting the bus anymore, and we're going to set the operation on the ALU. We're going to do that by selecting the selection pins on the ALU using these switches. For an AND operation, what we need is the selection pins to be set to 1, 1, 1, 0, and logical operations need the mode pin set high, which it is. So now the logic operation has been processed in the ALU, we need to move that over onto the output buffer and into the output register. We're going to do that the same way we've been doing it with the other registers, and we're going to set the control for these 2 registers low, and we're going to deactivate it, or we're going to have it float again by setting it high. And we can see that the expected output is shown on these LEDs. So next I'm going to show you an OR operation. So what we're going to do here is we're going to do the same process. So I'm going to load 2 more bit patterns from the input switches onto registers A and B, and select the operation on the ALU and move that onto the output buffer. The pattern for an OR would be 1, 0, 1, 1, and we're still doing a logical operation, so we still need the mode pin high. Now the operation has been processed, and we're going to move that onto the output buffer. And we can see our bit pattern was moved over to the output LEDs. Next I'm going to show you a adding operation between 2 4-bit numbers. So we're going to add the values 2 and 3 together, and 2 and 3, we should get a 4. So we're going to go through again the same process we did before by loading the values onto registers A and B and setting the operation on the ALU. So let's do that. So we have a 2, and we're going to load 2 onto the A register. And we want a 3, so we're going to load that onto the B register. Disable the input buffer. And now we need to set the operation on the ALU, which would be 1, 0, 0, 1. To select addition, and arithmetic operations need the mode pin to be set low. Now the operation has been processed, and we're going to move that over onto the output buffer. And we can see that we added the numbers 2 plus 2 plus 3 should be 5, and here we have the number 5 in binary. So thank you for listening. This has been a little presentation I made for a digital and microprocessors course assignment. Thank you for listening and watching.